Hello, geometry students. Here's your lesson for section 4-5, triangle congruence. Side, 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 and side angle side with Missy McCarthy, math instructor at Okemos High School. By the end of the lesson, you should be able to say that I can identify an included angle in a triangle given the two sides. I can explain why two triangles are congruent using side, side, side congruence postulate. I can explain why two triangles are congruent using the side angle side congruence postulate. I can identify which postulate proves that two angles are congruent, and I can prove that two angles are congruent using either of those postulates. So I know a lot of those sound very similar, and they are closely related, so we could have had fewer I can statements, but you'll see what I mean momentarily. So remember in the previous section how we were proving triangles were congruent by saying we had 3 pairs of congruent sides and 3 pairs of congruent angles? Well, in this lesson, I'm going to introduce you to ways that you can prove triangles are congruent without having so much information. And one of the things that we can use to prove the two triangles are congruent is called the side, 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 SSS for short, congruence postulate. And it says if three sides in one triangle are congruent to 3 sides of another triangle, then the two triangles have to be congruent. There's no way that you can take the sides, for example, 4, 6, and 7, and make a different triangle. If you only have those sides, then the triangles are going to be the same size and the same shape. That's called the side, side, side congruence postulate. So what this frees you up from is proving all 3 pairs of sides are congruent and all 3 pairs of angles are congruent. Now, it's going to be sufficient just to prove that all 3 pairs of sides are congruent. So, for that one learning target, explain why these are congruent. Well, we could say very, very simply that we are given that PQ is congruent to PS. Okay, so this side is congruent to this side. We are then also given that QR is congruent to SR. So this side is congruent to this one. And then lastly, we know that PR is in both triangles and it's congruent to itself by the reflexive property. And so using that reflexive property of congruence, so using those 3 pieces of information, we can say then that triangle PQR has to be congruent to triangle PSR because of the side, side, side congruence postulate. It is simple and acceptable just to say by SSS. A second congruence postulate that we have is side angle side congruence postulate, which says if 2 sides and an included angle of one triangle are congruent to 2 sides and an included angle of another triangle, then the 2 triangles are congruent. Now this can get slightly confusing because some people ask, what does it mean by having the included angle? What that is you have a side here, I just traced AB, a side here, I just traced AC, and notice how AB and AC make an angle. That is the included angle. That angle is the angle formed by those 2 sides. So we get side, angle, side, and side, angle, side. The angle is included between the 2 sides. So if this side, and the included angle is congruent to these 2 sides and the included angle, that is enough to say by this postulate that the triangles are congruent. So just notice, I'm just going to reiterate, the included side is the angle formed by the 2 adjacent sides of any polygon. So angle B is the included side between side AB and side BC. These 2 sides touch at point B, and so therefore this is the included angle. All right, so this diagram shows part of a support structure for a tower. We got to use side angle side to explain why these 2 triangles are congruent. So the first thing that we know that XZ is congruent to VZ. So we got 1 pair of sides. We also know that WZ is congruent to ZY. So we've got another pair of sides. So XZ and VZ Then we got WZ and ZY. So if we're going to use side angle side, we need the included angle. And the angle that would be included is this one right here and this one right here. So how do we know, let me get a slightly different color pen here, that angle XZY is congruent to angle WZV? How do we know that these two angles are indeed congruent? Well, because they're vertical angles. So by the vertical angles theorem, we can say that those two triangles are congruent now by side angle side congruence postulate. All right, show that these triangles are congruent by the side angle side congruence postulate, or by any congruence postulate. It doesn't say which one we're showing it by. So let's take a look here. We know that the sides of this one are 7, 5, and 6, but x equals 5, so that means that QR is 5. We then know that QP is 7, and we know that RP is 3 times 5 minus 9, which is 15 minus 9, which is 6. So we could say that the triangles are congruent by side, 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 because 3 sides in one triangle are congruent to 3 sides in the other triangle. All right, so here is our opportunity to do a proof. And we are going to either use side, 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 or side angle side to prove that these two triangles, triangle ABD, that's this one right here. It's nice to identify what triangles you're trying to prove are congruent. And we have to try to prove that it is congruent to triangle CDB. CDB, which is this one here. So you're trying to prove that those are congruent. So we'll have our statements and our reasons. And again, we're trying to get side, 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 or side angle side. So the first thing that I am given is that BC is parallel to AD. Whenever you are given that lines are parallel, 9 times out of 10, the next thing you should start looking for are congruent angles based on one of the postulates from chapter 3. 2 parallel lines are cut by a transversal, then some angles have to be congruent. In this case, I'm going to say this angle in my red triangle is congruent to this angle in my blue triangle. So my next step is going to be that means that angle CBD is congruent to angle ADB. Okay, and that is by the alternate interior angles theorem, because they are parallel lines cut by a transversal, which means that it's congruent. All right, so now this tells me I'm going to use side angle side because I've got congruent angles already. I just need the two sides to be congruent that make up those angles. Well, the next given statement that they give me is that BC is congruent to AD. So I got those pair of sides congruent. That was given. So that's this guy here and this guy here. Now the last thing I need is the other side, which happens to be BD. So lastly, BD is in both triangles, and it is congruent to itself by the reflexive property of congruence. And so now we've got those two triangles congruent because we have two sides and the included angle. So we can say that triangle ABD is congruent to triangle CDB, and the reason is side angle side congruence postulate. All right, so ask yourself if you can do these 5 things, and if you can't, don't worry, because we will practice them in class tomorrow. See you then.